Okay, here comes part 2. I actually had to go back and look at our notes because some of the slides were missing from the PowerPoint, so I just added them in for number 2 and 3. They were missing some examples. So we left off with this one right here, and you were told to go ahead and pause the video and work them out. So I am assuming you have finished part C and D. Let's check your answers. When you plug in -3 for x and evaluate that, you should get 7. So P at -3 equals 7. And for part D, you're plugging in 2 for x. So -5 times 2 is -10, and -10 minus 8 is -18. So M at 2 equals -18. Number 3, now we're turning it around and we're asking you to find x when given the value of the function. So if f of x equals -8, what must x equal in order for that to be true? So we are just replacing f of x. We're replacing that with the -8. So we just go ahead and write, it's like saying y equals -8, find x. So when you work your way backwards, just using basic moves of algebra, you're going to get -20 equals 2x, and then divide both sides by 2, and you should get -10. So x is -2. X is -10. And that causes f of x to equal -8. So that's true. If we were to graph this, and this looks like a line, doesn't it? It's linear. So we would have the point -10, -8 on that line. And by the way, when making a table of values and using function notation, you might also see that instead of having a y next to the x, it might say f of x. It's just another name for y. It's another name to describe the output. Okay, so it's referring to the range. Like this is referring to the range. Now give me the input, the domain value that gave you this output or range value. So replacing f of x with the 16 in this equation and solving for x. You would subtract 4 from both sides and then divide both sides by -2 to finish isolating and solving for x. So you get that x is equal to -6. So now pause the video and you work out problems C and D, and then unpause the video and check your answers. Did you get x was 5? And x is 11/4. Just because we get a fraction doesn't mean we did something wrong. Lots of times fractions are the correct answer. Life is messy. It's not always just about integers. Okay. So on example 4, we are given a graph and we're asked to find the domain and range and then determine if the relation is a function and explain our reasoning for it. So the domain are the input values. They're the x values. So let's go from order from least to greatest. So we're going to go across the graph from left to right. We see that this x value is -4, and this one is -3, and this one's -2, and this one's -1. So there you go. There's that set notation using the braces. You can use them or not. It doesn't matter, as long as you order these from least to greatest. And if we ever have any of the values repeating, we don't repeat them in our list of describing a domain or range. So for the range, we're talking about our y values. And again, we want to go from least to greatest, so we would go up the graph. So we've got this -5, and the -2, and the 1, and the 4, and there they are. And we can see if we were to put a vertical line across this graph, it just goes through those points only once, right? It did not go, let me go back and do it again. It's not going to hit more than once in any place. So it is a function. It passes the vertical line test. Each input has only one output. Now we've got these same in values, but now every point in between here is part of our graph, is part of our domain. So our domain starts with -4 right here for the x, and goes all the way over here to -1, but it includes all these other x values along the line segment. So remember, we use the x variable here for domain, so we're going to write it as a compound inequality. X is greater than or equal to -4, and it's less than or equal to -1. So it's sandwiched in between -4 and -1. And this will include all those little fractional numbers, those decimal numbers, all of them in between, and the integers. For the range, again, let's go from bottom to top. Let's go from least to greatest. And notice these are filled in endpoints, so those are included for our domain and our range. So our range will go from -5 all the way up to 4, and we use the y variable to represent range. So again, we can write this as a compound inequality to describe all the values between and including -5 to 4. And again, a vertical line is only going to hit that segment once. So yes, it's a function. It passes the vertical line test. Now pause the video and do the remaining parts of number 4, and then unpause the video and check your answers. Boom. Not a function. Fails the vertical line test. Each input does not have only one output. Fails the vertical line test. If these were open endpoints, we would use the less than only symbol right here and right here, okay, for either, yeah, for both of those. Actually, let's pretend like these were open endpoints and talk about the domain. It includes the -5, but it would not include the 3, so only this one would be less than. But for the range, these would both be less than because it's not including this and it's not including this, but all of the ones in between would be included in the range. So that's how that would change for the problem if you had an open endpoint. So let's see what you got for this one. -4 over to 3 and including. Again, watch out for open endpoints if you have them. From -5 up to 5. It should pass a vertical line test, so it is a function. Why do I not have any examples? Maybe it's too hard to do the PowerPoint with the open endpoints. Okay. What do you think? It's a function. Okay. So be prepared for a quiz the next class day. And how do I stop my video? It never wants to stop. Oh, what a pain. That's not what I wanted to do.